Hi, I'm Dylan.
Hi, I'm Josh.
We'll be presenting to you today the study of manufacturing surrounding disc brakes.
For the main disc component, we have three major components. The disc rotor, which rotates with the wheel, and it is the main piece of material taking most amount of the force during braking. There is also the brake pad, which is clamped to the brake rotor, which is fitted to the caliper from both sides of the rotor. And finally, there is the piston, which applies pressure onto the pads on the rotor to start the deceleration of the wheel. The disc brakes are found on most passenger motor vehicles, but we are focusing on the assembly on a car. A brake system can be worn much more depending on the user's driving style, and it could possibly be detrimental to its longevity and lifespan.
What can be seen on the current slide is just the full assembly of a brake disc. So you've got number one, the brake disc rotor itself being the main component, number two being the brake pad, and then three, just the brake pad housing.
Then we have the justification of the materials. So we're going to be using cast iron for the brake rotor and caliper. And the main advantages for that are the compressive strength and its castability. And for the brake pad, we're using ceramic composite. And again, the main advantage of that is its heat insulating properties, its high thermal shock resistance, and its corrosive resistant properties as well.
The manufacturing often follows the above flowchart, starting with a pattern design. A mold is created using techniques such as sand casting. This sand cast mold then has molten cast iron put into it, after which the mold is taken out of the furnace. It is then put into a cooling bath to ensure desirable characteristics are kept, and it is then trimmed down to remove any blemishes from the molding process. The disc then undergoes heat treatment such as annealing, quenching, and/or tempering to improve its strength and hardness. It is then subject to surface treatment to enhance its corrosive resistance and protect it from the elements it will eventually face when finally installed into the car. After the surface treatment, the brake is balanced by either adding or removing material where needed, and throughout the entire process, the brake undergoes different tests to ensure a quality product is being produced, such as X-rays, ultrasound testing, the Rockwell hardness test, or the Brunel hardness test. With the brake's final application being a rather higher risk one, there are high tolerances when it comes to dimensional specification and surface integrity to ensure a safe product is produced.
Finally, we have the environmental impact. As we have here, material wastage, which is the general term, is defined that any substance, material, or object that is not useful or not be useful is waste and is subject to any possible number of conditions such as landfilling, incineration, recycling, reusing, or composting. Um, we also have the manufacturing of cast iron with the use of carbon materials create hazardous air pollutants, being one of the largest being benzene when dealing with green sand molds. Sand casting often produces the most waste in the molding process, as after several uses, the molds become unusable due to the cracking that occurs to the high heat molds undergo, at which they will be disposed of, due to the sand's hardness, making it not usable in many other applications. Thank you very much.
Thank you.